So yeah, my name is Walt Gurley. I am a visualization and digital media librarian at the NCSU libraries. So today I'm going to be going over an open source workflow for creating web maps. There's a lot of ways right now to get web maps onto the web, but I'm really tired of seeing a whole lot of boring maps based off of I won't go that far, but I'm going to go over a way that we can start from some raw data all the way to a kind of more unique map using D3, which is a JavaScript visualization library. And so the workflow from going from raw data to a nice pretty map. So here's an overview of the workflow. So starting out on the left, we have some spatial data, in this case working with shapefiles, and then some non-geospatial data. It can be any type of tabular form. So combining those using a desktop GIS system, and in this case using QGIS, and outputting from that a GeoJSON file that we can then manipulate a little bit with some command line tools. And the tools I'm using are Topojson, which I'll go over a little more. And then from that Topojson actually producing something that you can view in a browser. So I am a huge proponent of open source software, so being able to use something without any proprietary needs. So that's one of the big reasons I push QGIS here. And the reason why I'm using a desktop GIS system is because the majority of vector spatial files we get are going to be shapefiles, and a desktop GIS is a pretty good tool to manipulate shapefiles in. And QGIS provides a pretty good resource for a good graphical user interface for actually manipulating these files. So whenever I'm messing around with data, I don't trust everything going on behind the scenes, so I like to actually be able to visually observe some of my data, and desktop GIS system is great for that. And also QGIS works on my Macintosh, so that's another plus for it as well. So to start out with, I'm going to walk through a sample data set that I put through this entire workflow, so you can see how we start out with some raw information and then end up with, in the end, a final map that'll display online. So I'm working with two data sets here. I have, it's census data, but I'm working with shape files that are US Census Tract geographic boundaries for North Carolina, and also demographic data by tract for North Carolina. So I have a shape file and all its necessary files, and then a CSV file as well. So these were both taken from the Census Bureau website. So again, I'm using open data as well. So here's where QGIS comes in to start with. It's a great tool for inspecting your data, for exploring your data, and also transforming. So it's got an easy built-in graphical user interface to bring in any types of data. In this case, I can bring in my shape file. I can also bring in my tabular data, the CSV. And with that, I can easily look at my table fields for each of my data sets, and I can identify, okay, if I want to join these two sets together. So that's kind of the goal of this right here, is I have non-spatial data and spatial data. How do I join them together? With this, I can easily identify they have a field that matches up. I'm lying a little bit because I did have to massage this data to get it in this format, but I have two fields that I know I can combine these two data sets together, and QGIS makes it easy for me to discover that. And then built in to QGIS are a lot of great tools. So with this, I can easily join. There's a table join method built into QGIS, so I can easily join these two data sets together. And pretty much with a couple of mouse clicks, I have one shape file now that contains the spatial references as well as the demographic data that I got that was in my general CSV file. So now I have my combined data sets. And in addition to that, QGIS provides some great resources for doing manipulations to tabular data. So I did just some field calculations to create two more columns of information that might be useful later on when I'm mapping. So I guess I should show that the data I'm working with, again, is census tracts, and then the demographic data I have are based off of race identification. So we have 5 different general categories of race that people would describe themselves. So that's the data we're looking at per census tract. And in addition to that, I created new fields based off of the size of a tract. I converted from meters squared to miles squared, and then also calculated the total number of individuals within each tract, so added up the different racial categories. And so once I've got my nice complete data set that I know I can mess around with, and I've actually viewed it visually, kind of testing it in the QGIS system, now I can export it as a GeoJSON file. So in QGIS, it gives you the option to just easily export as this type of file. You have one more chance to remove any necessary data. So for example, there was one column I did not need. So in the end, I'm going to be worried about file size. So I need to remove any type of data that's really not necessary for me. So I choose GeoJSON to export, and that generates a file. I don't know how easily it is for you to see this up here, but it's JavaScript object notation. So it's a great way to organize data if you want to mess around with it in JavaScript or view it on the web. And this is kind of the general breakdown of a GeoJSON file. So it's a described format, and it represents geographic features, like I said, in JavaScript object notation. And it consists of arrays of features. So we have a feature collection, and each feature is represented by properties and a geometry. So the geometry tells us how to map it, and those properties are any type of non-spatial data that we can associate with each of those features. And like I said, this format is a lot easier to manipulate in a browser than, say, a shapefile. And I don't know, someone can probably prove me wrong about that, but I don't mess around with shapefiles that often. Okay, so just to recap with QGIS, what we started out with a shapefile and a CSV file. We combined those together, messed around with some data, got rid of stuff we didn't need, and then exported it as a GeoJSON file. So now we're going from several files to just one file format here that we can easily manipulate. And this is where our command line tools come in. So I'm using a suite of command line tools called Topojson. And Topojson is actually a subset format of GeoJSON, but the Topojson command line interface allows you to actually convert GeoJSON files to Topojson files and then mess around with them some more. So why do I want to do that? GeoJSON, the file I just showed here, this format, is composed of coordinates. So each individual feature has a set of coordinates that indicate where it is mapped. So in that case, if we have contiguous geometries or places that are lying right next to each other, we're duplicating any coordinates if they're sharing the same coordinates. So this is where Topojson comes in. So it encodes topology instead of coordinates. So your geometry is represented as a sequence of arcs rather than coordinates. So this means if we have shared boundaries, we only represent that in our data set once. So we're not duplicating any information. And doing that, it means that we can reduce the file size. And again, why this is important, my end goal is to serve this via the web. So the smaller the file size, the less someone has to sit and wait for something to load. And I think that's pretty important these days when you're developing any type of web application. And so Topojson, it was developed by Mike Bostic. So he is the main developer of D3. And this module, again, it's for editing Topojson files, and you can get it via the Node package manager if anyone uses Node. It's a simple command line tool that there's a lot of good documentation on it on the D3 website. Apart from converting from a GeoJSON to a Topojson file, this suite of tools, the suite of modules that comes within this tool actually allows you to use other commands to simplify and reduce the size of your Topojson file even further. So it's all about generalizing the amount of information stored in this file so we can easily share it via a server. So the very first command that we need to do is actually convert from a GeoJSON file to a Topojson file. And here I just have, in black there would be the commands you would type into the command line. So it's just a simple 3-line. I tell it geo to topo is the name of the tool. And then I tell it what data I want to put in. In this case, I'm feeding in the GeoJSON file I spit out from QGIS. And I have it equal to tracks, and that's just kind of a naming convention. My individual features I named tracks because they're referring to census data tracks. So that variable right there could be literally anything you wanted it to be. And then I'm telling it to spit out a new file, nctrackstopo.json. So that's my new, now I have a Topojson file with just 3 lines of code. And looking at file size here, going from that GeoJSON file, it started out as 5.5 megabytes. After just simply converting it to Topojson, I've now reduced that size by about half to 2.7 megabytes. Next, I can reduce the file size even more. The Topojson command line tool comes with a module for simplifying your geometries. So there's a tool called Topo Simplify, and it takes in a few parameters, and then we feed into that our previously generated Topojson file, and then we output a new Topojson file that's been simplified. So the first line on the command line there, I'm calling the tool itself Topo Simplify, and this dash S 1 to the negative 8 is telling me about, okay, I want to simplify my file or simplify my geometry within a certain bound. So the actual algorithm that goes through this, I'm probably not the best at explaining it, but it's on the right here. It's a Viz-Bellingham algorithm. So it takes all your nodes of your geometry, and it measures the angles between them. So for example, I have a blue and a pink triangle between these nodes here, and it determines any of those angles that are smaller than the others, and it removes that angle. So going through time, I remove that first node of the corner of the pink triangle, and now I'm left with the simplified line here with the green triangle. It determines that's the smallest area left, so we remove that, and we ended up with 1 line. So that's kind of a generalized idea of what this Topo Simplify is doing it. And that 1 to the negative 8th is just saying, if I have any angle or triangle areas that are smaller than this, I want to get rid of them. So with that, going through that step, my Topojson file originally, 2.7 megabytes, pushing it through the Topo Simplify, I'm now down to 956 kilobytes. So we've drastically decreased the file size of our file. And just so you can see, get an idea of what that looks like, this is an online tool called Map Shaper. And it's a great way to just kind of test, as you're going through these command line steps, what's actually happening to your data. Like I said, with QGIS, I like to see what's going on. I don't always trust the command line tool. It's doing its job probably, but I don't believe it. So this was my original file here. This is the shape file we actually started out with. So if I zoom in to look at the geometry here, I'm going to overlay my simplified data file so you can see the difference in geometries between the two files. So that's why we got from 5.5 megabytes down to less than 1 megabyte now. And really how much you simplify is based on what scale you're going to be viewing your data. In this case, I'm looking at all of North Carolina. So if we're going from this resolution to this resolution, I'm not losing too much visual information in that case. And also, if command line tools aren't your thing, MapShaper, this online tool, has a built-in simplification method too, where you can import a shape file, simplify it in here, and then re-download it. So this is a great tool to be aware of as well. So it computes this all online. Okay, so we have a small file size, but we can do one more thing to make it even smaller. Let's see how small we can go. Topo Quantize is another tool with the Topojson command line module. And what that does, it generalizes the coordinates that make up our Topojson file. So Topo Quantize we call on the first line of our command line, and that 1 e to the fifth is a matter of how general we want to make our coordinates. So if you look on the top right here, what this quantization does is it first transforms float or decimal point numbers into integers, so it converts all that. And then from that, it converts the integers into delta x and y values, meaning each x and y value is dependent on the previous value of the x and y. So it's building up as it goes through, in this case with our Topojson file, the arc. And that's simply, we're just passing it in a parameter, and that one e to the 5, I don't know exactly what it's doing, so I had to play around with it a little bit, the 1 e to the 6 to 4 5 to see what actually kind of looked good. That's where Map Shaper came in again. So I can tell if I'm oversimplifying anything. I feed it in the last file I had and spit out a new one. And again, we're going from 956 kilobytes down to 718 kilobytes. And to recap all that we've actually been able to do with those command line tools, we'll see we started out with a 5.5 megabyte file, and we're down to 718 kilobytes. So that's about an 87% reduction in file size. So trying to serve a 5.5 megabyte map file on the web is really not fun. You can do it, but these days no one wants to wait around for that. Okay, so we've done kind of all the behind the scenes work. Now it's up to actually making something appear on the screen. And I won't lie and say that it's easy. This part actually, the D3 part is probably one of the hardest parts to actually mess around with. So if you're not familiar with D3, it's a robust JavaScript library for creating and manipulating visualizing and manipulating data. And the great thing about it and why it is so difficult, it gives you control over pretty much every aspect of the visual encoding of a visualization. So you have a lot of control over what your end product looks like. And D3 also includes a lot of great geospatial libraries. With those, you can do everything from geographic projections to drawing geographic data. So it's an extremely powerful tool, and it has a lot of great geospatial tools built into it as well. And the fact that we're using D3, we can take advantage of all the current web standards that are offered. So displaying something in a browser, we have a lot of strong tools for interacting with data, so you can use D3 to take advantage of events that are happening on a page. It has built-in animation tools, and it also does high-res imagery. So the fact we'll be working with scalable vector graphics this entire time, so resolution is not really an issue. And I guess also what should be said is with this, we can also develop a product that works across devices. So it works on desktop, nice big screen like this, down to a mobile device, so using responsive web. Okay, and to get started with pretty much any D3 project, these are your two initial files you'll be beginning with. And if you haven't done JavaScript or D3 before, this might be a little out there, and I apologize, but I guess we could do an entire session on how to do D3 and web development. But we're starting off with an HTML file, which is pretty much what you see when you visit a website. So that's kind of the styling of what a website looks like, or the layout of what a website looks like, and a JavaScript file. So inside of my HTML file, I'm importing two D3 libraries, in this case the main D3 library and also Topojson. So this Topojson is different from the command line Topojson in that the command line version we're converting from GeoJSON to Topojson. Problem is you can't display Topojson online easily, so this Topojson JavaScript file converts from Topojson back to GeoJSON so we can actually display it. Probably that might sound confusing, but it makes sense. And then in our JavaScript file, what we'll actually be doing there, that's where we're going to be loading our Topojson file that I ended up with. And then we'll be drawing the SVG of that Topojson file, and we'll use some loaded D3 functions to make all that happen. And in a JavaScript file, if I've preloaded D3, all of my D3 functions are available in the global namespace. It's just D3. So as I'm going to step us through a couple lines of code. So anywhere you see D3, I'm using a D3 function. Okay, so the first step to actually make this happen, we actually have to create an SVG canvas on our DOM. So D3 allows us to easily do that. So I just declare, I'm naming a variable SVG, and this is kind of the meat and potatoes of D3 right here. We're actually binding information to our digital object model, or pretty much our web page. So I'm telling D3 to select the body of an HTML page, and to that attach an SVG canvas. So this SVG canvas is what I'm actually going to be drawing my map on. And I'm giving it a few attributes. I'm just telling it the width and height of that canvas. So here, this is not a responsive. This won't end up being responsive. I'm setting the size of this to be 960 by 960 pixels. So this is kind of, I've created the canvas on which I will be drawing. All right, next, we actually have to load the Topojson file and create a features collection. So D3 has a built-in function for actually loading any type of JSON file. And since Topojson is in JavaScript object notation, we can use that to easily load in our data. So I just tell it what my file name is. And with that, I'm loading it in and storing it as a variable called tracks. And I'm using topojson.feature here to actually create an object array. So this might look familiar here, this tracks right here. This is pretty much the GeoJSON file I started out with after I exported from QGIS. And that might sound backwards, so I'm back to where I started, but it's all about that file load time at the beginning is why Topojson is nice. Well, there's some other good features, but don't have time to get into those. But it has an array of objects, and each feature has its geometry and the properties associated with it as well. So we can map something, and we can access all the properties available to us for that feature. Now, I didn't use a projection for my data, so D3 actually has some built-in tools for creating projections. You can pre-project a file before importing into D3, but I didn't do that. So next, I will create a projection. I'm using a conformal conic projection here, and I'm just setting, if I wanted to look at a projection of North Carolina, these are the parallels and the rotation I would use to focus on North Carolina. And then this fit size at the bottom here is just a convenient way for me to make it fit into that SVG I created. And now this is where all the actual drawing of the SVG takes place. I'm not going to go over all of this right now because I don't think it would be worth our time. I'm actually going to show you what it ends up looking like. So what you see right here is finally this map that we end up with here. So what I'm looking at, back in my file, I wanted to look at the proportion of American Indians to the total number of individuals within a census tract. And visualizing that just with changing, I'm using a hue, saturation, luminance scale here. So I'm keeping the hue standard and the luminance standard and just varying the saturation based on the number of individuals who identify as American Indian in a census tract. So that's the simplest way. I think this is all the code that goes into making that happen. So if you were to spend some extra time and add some more information into doing that, here's an example. So now I have an interactive drop-down menu and a nice color scale to look at. We're going to look at area squared, the different types of race identifications and census tracts through North Carolina. So this is kind of the end product that you can end up with a little bit more effort. All right. And with that, I'm good. So if you want to check out those two D3 maps I just showed you, they're available in CodePen, meaning you can go in and you can edit the code and play around with them yourself. So here's links to those. Thank you.